Okay, this is Degrees from CS50's Introduction to Artificial Intelligence, Week 0 problem set. So the purpose of this problem is to find the shortest path between two actors, kind of like the Kevin Bacon number. So it's going to look something like this. We can put in the name of any two actors, and it will tell us if there's a connection, and if so, how many degrees of separation there is. And for this one, of course, those two are not connected in the database. I think they probably would be if we had a more extensive database. Right, we have a smaller database that's quicker to work with. All right, and that shows us 2 degrees of separation between Tom Hanks and Demi Moore. That sounds pretty accurate. And of course, the big database takes a while to load. And while that's loading, I'll explain what's going on here. So they gave us a distribution code, which has almost everything filled in except for this function here, the shortest path function. And that's our job to fill in. So to find the shortest path, we need to start, of course, from the source. And we'll create the source node. And every node is going to hold the state, which in this case is just the actor's ID, the parent, if there is one, and of course for the source there is no parent, and the movie that they acted with the parent in, and in this case, of course, there is none. All right, so then we take that source node that we just created, and we're going to add it to the frontier, and for this set we're using a Q frontier, a breadth first search. So we're going to be searching the options most closer to the source first, trying to find the shortest path. All right, we add that to the frontier, and then in order to expand our frontier, we take the first node in line from the queue and search for its neighbors. And in those neighbors, we're going to be looking for the target. And if we find the target, we create a target node, which has the ID of the target, of course, the parent, which is the previously explored node, and the movie ID in which the target and the previous node acted together in. Right? And we work our way backwards through all the parents and all the movies, finding that path. And if we do not find the target among the neighbors, then we're just going to, for every neighbor, create a node and add those to the queue. And we're going to search them the same way we just searched. And let's do our last search here. So, that'll pop up like that. It shows 3 degrees of separation, which is also probably pretty accurate. So I noticed something while I was when I was playing with this, is that, let me check my time here, is that the search times was varying every time. And when I did a little bit of digging and made it print out the number of explored nodes, I was finding that sometimes for 3 degrees of separation here, it was less than 50 explored nodes, like 42, 46. But usually it was somewhere, it was in the upper 90s, over 100. I saw up to 160 for these same two actors. And I decided that maybe I needed to sort the neighbors before I added them to the frontier. And I decided to sort them based upon the number of movies they've acted in. I figured that if an actor has been in more movies, then they'll have more neighbors, and it's more likely that you'll find the target among those neighbors. And overall, that's shown to be pretty accurate for this search here. On average, before I sorted it, it was coming up to about 90 explored nodes to find 3 degrees of separation. And after I started sorting, it was 52 every time, and it was bringing me back the same results. For longer searches, I searched for Fred Durst to Eminem because I thought it was kind of funny. And before sorting, I found something like 3,000 something explored nodes to find their 5 degrees of separation, and after sorting, I got that down to 1,200 every time. So it's not going to be the most efficient search every time, but on average, it increased the efficiency of the search function. So I think my heuristic there has been at least somewhat successful. So anyway, this was Degrees, and I'll see you next time.